All right, the final example I want to show you today, this one has some reduction possibilities in it. Okay? And again, I just wanted to do this one just to make sure that you understand that reduction is allowed in places, just not everywhere. All right? So, descending order equals 0. We got the proper structure to begin with. So job 1, I want the lead coefficient to be 1, right? So I'm going to divide everything by 12. So this divided by 12, this divided by 12, this divided by 12, this divided by 12. So 12x squared divided by 12 is x squared. 38 over 12 reduces to 19 over 6. And 20 over 12 reduces by 4 down to 5/3. That's the first thing I want to do. I want to divide everything by 12, and again, in that step, reduce as many fractions as you can. That's fine. There's no problem with reducing fractions there. In fact, it makes the problem easier to reduce fractions there. It's worth doing, and it should be done. So I always look to reduce. The first two examples didn't have any reduction possibilities at all. This one does, so do it. Step 2, x squared, 1x squared, we're ready to go. X squared and x down one side, 5/3 moves to the other side. It becomes negative, so x squared minus 19 over 6x is equal to negative 5/3. Once again, when taking half of the fraction, half of this 19/6, 19 is an odd number, so I'm going to double the bottom. So I'm going to be adding 19/12 squared to both sides.
Wait, what? Oh.
Okay? And again, it's 100% of the time that's how you take half a fraction. You double the bottom if it's odd on top. You take half the top if it's even on top. That's just how you half a fraction. Just shouldn't be any thought process necessary there. Here, let me show you, and sometimes people don't know why, so let me show you why. 1/2 times 8 over 7. What kind of top is that?
Even.
Half the top.
Wow.
All right, 1/2 times 5/9. What type of top is that?
Oh.
So it doesn't divide, right?
Yeah.
So you end up doubling the bottom.
Whoa.
Both cases it's half a fraction. If the top happens to be even, you can divide it by 2. If it's not, you can't, so you got to double the bottom. That's why it is what it is. All right, so we're going to be adding 19/12 squared to the left. So we have to add 19/12 squared to the right. 361 144ths. So, common denominator is 144. So this has to be multiplied by 48. 3 times 48 is 144. So 5 times 48 is 240. And notice that's negative 5/3, that's negative 241 144ths.
What did you say we multiplied by?
48. All right?
Nice boys.
So, common denominator is happening. We have perfect square trinomial on the left, we're ready to go. So again, parentheses squared goes over here. The middle term is minus, so it's minus. X squared, square root is x. 19/12 square root is 19/12. On the right hand side, negative 240 plus 361 is 121. Does 121 over 144 reduce?
Oh.
First of all, no. Second of all, I don't care because I'm not going to reduce that. All right? Don't reduce that ever. All right, but if it did reduce, I wouldn't reduce it. It doesn't reduce it. All right. Final step. I got squared equals number, right? So I'm going to take the square root of both sides. X minus 19/12 for this side. Notice 121 is 11 squared and 144 is 12 squared. In that case, both the top and the bottom are perfect squares. That happens occasionally. When it does, you should actually evaluate them both out to nice, pretty whole number answers. Plus or minus 11/12. And now when I move the 19/12 over, notice we have that common denominator happening again, right? Over 12. I'm moving a negative 19 across, becomes positive 19, plus or minus 11. Do not leave your answer here. The last two problems, we had number plus the square root. We couldn't add or subtract that, right? 19 plus 11 equals 30. And 19 minus 11 equals 8. And both those fractions reduce. Let's see, that reduces by 6, right? Down to 5/2. And that reduces by 4 down to 2/3. If this ends up being a perfect square, so you get a nice, pretty square root like this, you should end up with 2 regular answers like that. This plus this makes the top number, this minus this makes the other top number. They're both over the common denominator. Reduce the fraction if necessary. These reduce fine. No problems reducing here or here. Just don't reduce that term. Ever. Never, ever. In your entire life.